transfer function to state space model. State space model. Okay, right. We will see this. Suppose, for example, you take the transfer function of a given system like this. Y of s by u of s is equal to some b naught divided by b naught divided by s power n plus e1 s power n minus 1 plus a2 into s power n minus 2 plus and so on plus a n minus 1 into s plus a n. Okay, suppose say you have this kind of transfer function, then this transfer function you should convert into state space model. If you previous example we have seen, if we have the differential equation, then how to do it, we learned it. From the transfer function we can get the differential equation, right, by taking inverse Laplace transform. So we try in that way. For that we will do cross multiplication. We do cross multiplication. Therefore what we get, y of s into s power n plus e1 s power n minus 1 plus and so on plus a n minus 1 s plus a n is equal to b naught into u of s. Now y of s into s power n, if it I will write separately. I will split these terms. S power n into y of s plus a1 into s power n minus 1 into y of s plus and so on plus a n minus 1 into s into y of s plus a n into y of s is equal to b naught into u of s. Now take the inverse Laplace transform on both sides. Inverse Laplace transform. Inverse Laplace transform on both sides. Then what you get? Then we have this s power n into y of s. How can you write? Pallavi, s power n into y of s, inverse Laplace.
1.
No, it is the nth order derivative d power n by dt power n of y plus next term is a1 into d power n minus 1 by dt power n minus 1 of y plus and so on plus a n minus 1 s into y of s is dy by dt, right, plus next a n into y is equal to b naught into u of t. Okay, yeah. Well, we understood.
Okay, sir. Yes, sir.
Yeah. Now in this, we need to select the state variables from the differential equation. How many state variables required? How many state variables required?
N.
N state variables. Therefore, n state variables we select like this. Starting output variable is taken as the first state variable. Next, its first order derivative is the second state variable, and Next derivative is the x3 and so on. We will select. So we'll write here. Therefore, state variables are selected as x1 is equal to y, x2 is equal to dy by dt, x3 is equal to d square y by dt square, and so on. Xn minus 1 is dy dn power minus 3 y by dt power n minus 2. Sorry, here 2. Then xn is equal to d power n minus 1 by dt power n minus 1 of y. Okay. Now, from this, what is x1 dot?
dy by dt.
Dy by dt, that is equal to
X2.
x2. x2 dot is equal to
X3.
x3. x3 dot is equal to
X4.
and so on. X n minus 1 dot is equal to
Xn plus 1.
xn.
Yes, sir. Xn.
xn. And what is xn dot? Xn dot is equal to d power n y by dt power n. Correct?
Yes, sir.
This is equal to, from this equation, from the first equation, is equal to this total we should transfer to the left right side. Correct? Then what you can write, an into x1, I mean minus an into x1 minus an minus 1 into x2 and so on. Correct? So minus an x1 minus an minus 1 x2 and so on minus a1 into x n a1 into xn, and this is plus b naught u, plus b naught into u. All have understood this?
Yes, sir.
Okay. Now, from all these equations, we can write the state equation in the matrix format. Therefore, state equation is x1 dot, x2 dot, and so on, xn dot is equal to some n by n matrix, big matrix, and again x1, x2, and so on, xn plus 1b matrix into u. Then tell me this matrix from the first equation. What is x1 dot? Is
X2.
means x1 coefficient,
1.
x1 coefficient 0,
0.
x2 coefficient,
1.
x3 coefficient 0,
0.
and so on. Correct? All are zeros. Next, x2 dot equation. It is x3. So the coefficients are
1.
how it is 1.
X2 dot.
x2 dot is equal to x3 only. So
Yes.
x1 coefficient
0.
0, x2 coefficient
0.
0, x3 coefficient,
1.
and so on. Next till 0, next to 0 and so on 0, next and so on. Then last xn dot
10th position it
if
will.
you continue it will be like this. Correct?
Yes. Yes, sir.
like a first column, if you remove, it is like a full identity matrix. Last column, x1 coefficient minus an.
Minus an.
Next, minus an,
Minus an minus 1.
and so on. Last coefficient a1. A1, correct?
Yes, sir.
Next, this matrix.
B naught 0.
0. Zero, correct?
Yes, sir. All zeros.
All zeros.
B.
Last
B naught.
So this totally called as state equation. Here, if you observe this, except the first column and last row, remaining total is the identity matrix, correct?
Yes, sir.
This is completely an identity matrix. Only this first column elements and last row column last row elements are changed different. And see, this format is fixed for any kind of problem. If you know what are these differential, if you know the differential equation, means you can write directly in this matrix format. No need of calculating the equations, no need of assumptions and all. Directly you can write this. And here U matrix also all are zeros. Only B naught coefficient is there at the end, because numerator we have only one coefficient. So this format is applicable only for the transfer function when it is in this format only. Okay. I mean numerator we have only one coefficient, then only it will it is the output is this format. This is the state equation. Okay. Similar way, output equation, that is y is equal to x1, correct? So y is equal to x1. This is fixed. So the matrix is equal to 1, 0, 0, and so on 0 with state variables x1, x2, and so on xn. It has only x1 coefficient. Plus u is not there. So its coefficient is 0. So this matrix, C matrix and D matrix both are constants. C matrix and D matrix are constants always. Only this A matrix is different, B matrix is different. Okay? Understood this?
Yes, sir.
And this method is called controllable canonical form. This method is called controllable canonical form. CCF, in simply CCF we call it as controllable canonical form. Okay, this format, this total state equation and output equation, if these are in this format, then this is called controllable canonical format. Okay. And same thing, sometimes they will also ask not only the explanation of controllable canonical form, they'll ask to get the state diagram, signal flow graph, state signal flow graph, you can say. So we will draw the state signal flow graph. Do you remember or not? I told you already to draw the diagram. assume the u variable input is at the leftmost corner and output variable at the rightmost corner. Since it is a signal flow graph, I am putting the nodes. So this is the y node. This is sorry. This is u node. This is y node. And from the first equation, we know that x1 is equal to y. Therefore, it is coming from the x node directly. This is x1 node. Okay, understood now? Now, next question, next is x2. X2 variable is nothing but dy by dt. That means x2 is equal to simply x1 dot. That's it. So how to get x? How to get x2? So this is x1 dot. That is nothing but x2. So how can you get x1 dot? If you take it integral of this, integral is nothing but 1 by s. Okay. If you integrate this x1 dot, you will get x1. Similar way, how to get this x2 from x2 dot? So x2 dot is equal to x3. From this x2 dot, we will get x1, x2 by integrating x2 dot, and so on. Same thing, we can do it. And here, finally, you will be having x1, xn minus 1 dot. That is nothing but xn. Okay. And how to get this xn minus 1 dot? Sorry, xn from xn dot. If you integrate this xn, you will get xn, xn dot. If you integrate, you will get xn. Okay. Now, after this equations implementation, now till xn minus 1 we did. What about xn? Xn is over. X1 dot over x2 dot over x3 dot over and so on. Xn minus 1 dot is equal to xn. Till this point it is over. Then next question is xn dot. This is equal to minus an x1 minus an minus 1 x2 and so on. So how can you do that? This is taken from xn. This is x1. From x1, I will take this to xn with the multiplication gain of minus an. Okay. Now x2, from x2 also we have, but with the coefficient of minus an minus 1 to the same point. It is minus an minus 1. Okay, and so on. Here, this x3 also we have x3. From x3 we have minus an minus 2. Now we have some and so on. We have same thing. We can continue this routes. Okay, this is the state diagram in signal flow graph representation. Understand this? Already output equation is designed here. Y is equal to x1 only. Pallavi, understand this?
Yes, sir.
Okay. This is the state signal flow graph. Sometimes they will ask to draw this. That's why I'm telling you. Okay. Then we'll do a small problem on this controllable canonical form. Simple problem we'll see now. Later we'll continue that problems. The obtain the state space model for the given system. What is that system? Y of s by u of s is equal to 2 by s square plus s plus 1. Okay, this is the system. Simple system. Please do this. Given transfer function y of s by u of s is equal to 2 by s square plus s plus 1. So do the cross multiplication. Then what do you get? Y of s into s square plus s plus 1, that is equal to 2 into u of s. Okay. Then if you take the inverse Laplace transform, then s square into y of s is equal to d square y by dt square. Then this is equal to s into y of s, dy by dt plus 1 into y of s. It will give y. This is equal to 2 into u. Now you assume this is x1, this is x2. Because it is second order equation, two state variables enough. Now therefore state variables are x1 is equal to y, x2 is equal to dy by dt. Therefore x1 dot is equal to dy by dt, that is equal to x1, and x2 dot is equal to d square y by dt square. From the first equation, from this equation, we can write d square y by dt square is equal to this, move to this side. So it is equal to minus 2 into u minus dy by dt minus y. Here y is equal to x1. So minus x1. So okay, I will write this 2u minus this is x2, this is x1. So if you write in the order, it is minus x1 minus x2 plus 2u. Okay, this is x2 dot. Now from the second equation and third equation, we can get the state matrix. What is the state matrix? Therefore state equation matrix is equal to x1 dot is equal to a 2 by 2 matrix into x1 x2 plus something, I mean a 2 by 1 matrix into u. What is here in the values?
1,
1
0.
1. How it is 1?
X1,
This is x2
0, 1.
0 1. This is
2u, not 2u, 1, minus 1, minus
minus 1.
2,
B matrix?
2, sir.
No.
0, 2.
0 2, right. Okay, and see, this is nothing but we have this, no, when you compare this with the general format, it is b naught, okay, divided by s power 2 plus a n minus 1 into s plus a, sorry, a n minus means here it is a1 s plus a2, correct? Just compare with this. Then what is b naught here? 2. Therefore, see here, in place of b naught we got 2. General notation. If it is this, what is the x1 dot x2 dot we should write? Here it is a matrix. Here it is an identical matrix. First row it is 0 1 0 0 0 0. Then next row, since next row is the last row is minus an minus an minus 1 and so on, correct? Minus an is here minus a2 and here minus a1, correct Pallavi? Here 0 0 0 0 last b naught value into a.
Yes, sir.
Now you fill these values. Simply 0 1 here constant, minus a2 is minus 1, minus a1 is minus 1, and this matrix 0 2, right? So if
Yes, sir.
you remember this format, directly you can get the answer. If you don't remember, please do the steps. Equation 1 and assume the state variables and find out the state matrix. This way, whichever you like, you can follow it.
Depending on marks, we should do the problems.
Any marks are not an issue here. But
Okay.
in this format, if you want to do, be careful. If this format exactly no, then your answer will be correct. Otherwise, something will go wrong. You
Okay.
should mention the general format first, then you can place the answers. If you don't remember, I suggest this derivation. It is not a big derivation also. Okay, right. It's up to you. Your wish. Both will give you the same marks. Nobody will cut. And this is the state equation. Therefore, output equation y is equal to, since y is equal to x1 always in the controllable canonical form, this matrix is fixed only. 1 first, then 0 0 0 zeros. X1, x2, and D matrix is always 0. That's it. Over.